Good morning, all. Good morning, all. You are welcome to Tutorials with Fametante the Schoolboy, the 2023/2025 Circle B, Circle Class B. So we review our chemistry assignment review 2. Number one question says, which of the following scientists discovered the neutron? A. Ernest Rutherford. B. J.J. Thomson. C. James Chadwick. D. R.A. Millikan. What's the answer? Chinwe. A is what? Ernest Rutherford. Who agree with her? You agree with her? Huh? You all agree with her. Electron was discovered by James Chadwick, not Ernest Rutherford. Neutron was discovered by James Chadwick, not Ernest Rutherford. Why do you say Ernest Rutherford? Huh? Which textbook is that? Okay, let's see. New chemistry is here. So anyone you just look at it. We don't waste time. That's why it's a review. It's not a normal lecture. We review. We check. If you are correct, then you have it. Rutherford. Okay, let's start from neutron. Discovery of neutron. In 1932, Chadwick bombarded a thin sheet of beryllium with alpha particles and discovered a new subparticle called the neutron. Modification of that's atomic theory. What happened there?
Discovered some atomic particles which are proton, neutron, and electron.
And what?
Proton, neutron, and electron.
Where is it?
In John.
Number 1. This statement has been proven wrong by Rutherford's discovery. The atom is built up of 3 main types of subparticles: the proton, the electron, and neutron. That doesn't say that Rutherford discovered neutron. You just say it proved wrong by Rutherford's discovery. The atom is, but Rutherford is not the only scientist that work on the atom. Hope you know. James Chadwick discovered what? Neutron in 1932. It's clearly written here. Okay? Good. Number 2 says, what phenomenon is exhibited by an element Z? What phenomenon is exhibited by an element Z which exists as 35 as in atomic? Look at it here. Which exists as mass number 35, atomic number 17, then Z, and the mass number 37, atomic number 17, Z. The question says, what phenomenon is exhibited by an element Z which exists as these two? What type of phenomenon is that? Isotopy. Is it true? Chiwa, is it true? You're not sure. You're not sure, right? You don't know it. Is it true? Are you sure? I told you here that isotopy is a phenomenon whereby what? An element does what? Exists in what? Okay, we whereby 2 what? Is it 2 or the same element? Atoms of element have what? The same what? Atomic number, but difference in what? Due to what? Difference in number of what? Neutron. We explain it here. Now what caused that difference in mass number is the difference in the number of what? Neutron. Because mass number is neutron plus what? Electron. Is it clear? Is it clear? So I think I agree with you. The answer is isotopy. 2b says, what accounts for the difference in the mass numbers of the element Z above? What accounts for the difference in the mass number of the element above? Difference in what? In number of what? Neutron. Good. Alright. That's good. I agree with you. Number 3 says, an element X has 2 isotopes. We call it X65. Like if you want to call this, look at these 2 isotopes of Z. If you want to call this isotope, you say Z35, Z37. Okay? Z35, Z37. So if you want to look on this now, it's called, it has 2 isotopes. X what? X65. That means the mass number is what? 65. Atomic number is what? 30. And X60 what? X66. What means that mass number is 66. And if you watch now, they have the same number of what? The same atomic number, but difference in the mass number. That's why they are so this one is X65. That is same element, hope you know. Are you aware? But they differ in their physical what? Property. They differ in their what? Physical property. Their chemical properties are what? The same thing. Now, this is X65, X66. The question now says, an element X has 2 isotopes, X65 and X66, with relative abundance of, can't sit well, that is not how to sit in class. With relative abundance of 60% and 40%. So this one has relative abundance of what? 60%. And this one has abundance of what? 40%. Because it now says the relative atomic mass of X is what? What's the answer? Children, what's the answer? Is what the answer? Aizu? Can't what's the answer? Okay, anyway, we have not done this calculation, but it's good we will review so that this will help you to, when you now open your book, you understand it better. Listen carefully. Remember we said, do you know what? Have you noticed that between the atomic number and mass number, which of them normally come as fractions? Sometimes. Mass number, right? Something like chlorine. Chlorine is 35.5, right? Right? There are something like copper. Copper is 33.5. There are some almost all of them have decimal point. Do you know why? Because they have what is called what? Isotopes. So the relative atomic mass is actually calculated from the what? The average of these isotopes, okay? Average of the mass numbers of these what? Isotopes. That's how they calculated this relative atomic mass. Do you know why the relative atomic mass of chlorine is 35.5? 35.5. I will show you. Different elements have a lot of, you may see an element that may have up to more than 10, 20 or more isotopes. But the isotopes we normally use is one that has greater what? Abundance. Okay? Abundance is how they appear in nature. Am I concrete? That's the meaning of abundance. What means that this element appears more in what? 65, X65. Am I concreting? more than the one in what? 66. Okay? So if you now use this relative abundance, if you now use their percentage now, if you want to calculate the relative atomic mass of this X now, see what you will do. Even if they are up to 50, you do the same thing, but since there are two, see what you do. Find 60% of this 65. Write it down. Find 60% of this 66. Write it down and add it together. Whatever you get is the mass number of what? Is the relative atomic mass of the what? Of the what? Elements. Now we have two chlorines. We have chlorine. Two major, the one that major ones. We have chlorine 35 and chlorine what? 37. I think chlorine 35 is the one that is more in abundance. I think so. I think it's around. Of course, they have the same atomic number. Hope you know. You know that, right? But our concern is the what? Mass number. But this chlorine now, I think it has 75% abundance. This one, chlorine 37, has 25%. You know how to find percentage of something now, right? Right? Now, find this 60% of this 65 and keep it by side. Find 40% of this 66 and keep it by side and add it. Tell me what the answer is. Then let's go to chlorine. Find 75% of this 35. Write it down. Find 25% of this 37. Write it down and add it. And it should give you, if we got this abundance correct, it should give you 35.5. Oh yeah, do it now. Fast. What's the answer? Okay, you're not yet. You're not done yet. You're not helping yourself. You're not helping yourself. She right down. I am doing this. Huh? No, remember. Okay, what that we have to calculate it? What they say? Huh? How? What am I saying? What I say about how to calculate relative atomic mass of an element from the isotopes given? What they say now? I said it. Huh? You do what?
60% of 65.
40%
of 65.
Then add the two of them. You say I didn't say anything. Huh? You say what? You didn't? And you say that I didn't say anything. That's wrong now. You don't talk like that. Don't say I didn't say anything. Say I couldn't solve it. Not that I didn't say anything. It's not good. Huh? 65.4. What do you get here in this one? For X65? 39. Are you sure? Did you approximate it? So what do you get for X star? 66. 26.4. So you add it all, then you got what?
65.
So 65.4 is the relative atomic mass of what? X. So do for chlorine. You know I told you that the relative atomic mass of chlorine is what? 35.5. If you do for that, if you do for the chlorine now, you will get 35.5. I told you that these are the common isotopes of chlorine. That is where they got that they did this calculation and arrived at the fact that the relative atomic mass of chlorine is 35.5. So do it. Sometimes you may be given about up to 10 isotopes or 4 isotopes and their respective abundance. It's simple. Just be calculating their what? Percentage of their, use that abundance. Calculate if the abundance is 20%, then find 20% of the what? The mass number. Do it for all the isotopes and add it. You will get the what? The relative atomic mass of that element. So do for chlorine, let's see. Do for chlorine, let's see. The 5.50. Use calculator.
No.
So what do you get for this? Chlorine 35.
It's 6.25.
Chlorine 37.
9.25.
9.25. Have you not seen why the relative atomic mass of chlorine is what? 35.5. That's the reason. It's from this calculation, okay? So let's go back to what we are solving. So from here now, what is the answer now to this question? The answer is what? B, 65.40. Is it clear? Is it clear? So that's how why is the answer is 5.40. So I believe that if you see quick question like this, you can solve it. Three of us. I know that this Zu and Kamsi are having his calculator. Three of us. Did you solve it? You got the answer. I know that this Zu is having his calculator. You know it because I've told you how to solve it. But the every issue to do that, please don't be too used to. But don't get too used to calculator that you cannot do some things on your own. It's not a good thing. Now let's continue. Number 4 says, give two differences between a physical change and a chemical change. Give two differences between a physical change and a chemical change. Number 1. Chibuzo. Two differences between a physical change and a chemical change. Number 1 is what? What are you saying? Is that what?
I said physical change are not chemically combined.
You're talking about
No.
mixture. Why are you laughing? You are describing mixture for us. I say physical change.
Physical change is not from new substance. Chemical change from new substance.
Good. Number 2, Chinwe. Speak out. Let's hear you, please.
A physical change is a temporary change.
Temporal change. What is my temporal change?
Like, it's the same thing.
Is Chugu? Oh yeah, is number 2. It's not easily reversible. I agree. I agree with you. Physical change is what? Easily what? Reversible. Come see. Please, we are recording this thing. Project your voice, please. I want you to learn how to project your voice, please. It's very important.
A physical change, new substance, no new substance is formed. Why the chemical change?
Chibuza has already said that one. I gave you up to 4 to 5 differences. So what are you saying? Number 3 is what? Wait, let's come see answer it. Comes answer ya. What will these things here? You are still reading your book now. It's a sign that you don't read. You should be in your head by now. It's not true. And I also give this. So I telling me that you are exposing yourself 2 times. You did not read it, and you did not do the assignment. That's the meaning. Then why are you putting your books? Okay, only 2 you wrote. So what are the one we did in the class? Go back now, uncle. Chibuzo. You say what? Please be careful. Please let be serious. We are serious business here. Please, we are not here to play. Answer the question I asked you. The third one. Give us the third one. Okay, you don't know any other one. Chichiwandu. You don't know how many Idagi people in the class? How many Idagi people in class? Okay, you can add this to the one. Please study. Study, please. Don't just come here and go without reading your books. I know what I'm saying. So the money your parents pay here will not be a waste for you. In physical change, heat change is not involved. There's no heat change. Heat change is not involved. When we go to, when we move further in chemistry, we do what is called enthalpy of reaction. But for now, we just take it at this level that heat change is not what involved. But physical heat change is not involved. But in chemical change, heat change is involved because heat is given out or absorbed. In chemical change, heat change is involved because heat is usually given out or what? Absorbed. Heat change is involved because heat is usually given out or absorbed. Number 4. Any other idea? No other idea. Please let us not waste our time on this. In the physical change, there is no change. There is no change in the mass of the substance. So there is no change in the mass of the substance undergoing physical change. There is no change in the mass of a substance undergoing what? Physical change. So there is no change in the mass. The mass remains the same in physical what? Change. But in chemical change, there is what? Change in the what? The mass. There is change in the what? The mass. Let's go to the last question. Last question says, Pauli's exclusion principle. Pauli's exclusion principle is related to. Pauli's exclusion principle is related to A. Quantity of electrons in the valence shell. Quantity of, that is quantity of, not quantity electrons. Quantity of electrons in the valence shell. B. Filling the orbitals with lower energy first. B. Filling the orbitals with lower energy first. C. The filling of degenerate orbitals. The filling of degenerate orbitals. D. Quantum numbers of electrons. D. Quantum numbers of electrons. Is what the answer? That's what's the answer. Chima, what's the answer? Huh? Choose what's the answer? Quantum numbers of electron. We'll still do it anyway, but you know there are about 3 rules that have to do with filling of orbitals. We have the one we call Pauli's exclusion principle. We have Hund's rule. We also have Abel principle or Abel rule, something like that. Now, Pauli's exclusion principle is just trying to let us know that all the quantum numbers in the electrons in the orbitals can never have the same quantum numbers. They can never have the same quantum number. You know, we have 4 quantum numbers. So it's not possible to see 2 electrons that they're having exactly the same the same value for all the 4 quantum numbers. That's what Pauli's exclusion principle is trying to let us know. That it's not possible to see 2 electrons that have exactly the same value for all the 4 quantum numbers. They may have the same principal quantum numbers. They may have the same magnetic quantum numbers. They may have the same subsidiary also, but they may not have the same spin. Okay, so we'll go into that. Okay, yeah. So that's what. So the policy execution principle is talking about what? Quantum number. So the answer is D. The answer is D. I agree with you. That the answer is what? D. All right, please. That's the end of our review. Please ensure you've copied. Please let us not come. If you come late to this class, you become confused. Have you noticed that? Have you noticed that? Anytime you come late to my class, you'll be confused. Throughout the class, avoid coming late. If what you are coming here to do is important to you, avoid coming late. If you come late, you'll be confused. Always ensure you are there before time. Instead, be there and waiting for me to start than coming when I've already started. If you enter, you do know you are left from your right, you're confused. And if you are confused today, confused tomorrow, I don't know, you will even become tired. Please always come to class on time. It's better you are here before I start than coming late. Those that children that came late now, you didn't copy the assignment. So how will he now do the assignment? Please ensure you copy the assignment. If you did not come on time, please always come on time. What of the other ones where we without break? Just only 2 hours. What will we now do? You copy it where? When it's already late in the night. Please come to class on time, please. Now, I told you if Saturday work is one holding you, do it on Friday. Clear it on Friday because you know that you have a very hectic Saturday. I avoided a lot of things to ensure that I'm here with you. I sacrificed a lot of things. Even in the office, I ensure that I don't want to disappoint people. That's why if not, I would have told you, please go back, let me go and attend to some things. But I abandoned it and come here. So why will you come late? It doesn't make sense. Please stop coming late to class, please. All right. All right. Do you have any question on this review? All right. In the absence of any question, I think we'll stop here. All right. Thank you very much for your attention. God bless you.